Very good morning, friends. This is Hemant Pradhan. Again, welcome you to this YouTube platform, that is e-learning hub YouTube channel. So, dear friends, in our earlier classes, we have already talked about how to evaluate the limits. Okay, how to evaluate the limits, and in that we are facing the two types of problem in calculating the limit. That is your what algebraic limit, another is your non-algebraic limit. Okay, and algebraic limit are those limit where we are not having the trigonometric function, inverse trigonometric function, exponential function, and logarithm function. So such type of functions are called your what non-algebraic limit. But whenever we have other than this form, that is called your what algebraic limit, like your what polynomial form, and your if the we have to calculate the limit of a where the square root is given. So such type of function is called your what algebraic function, we can say. And having that, we are going to calculate the algebraic limit, and we have already discussed the different methods to calculate the algebraic limit. So there are actually basically 5 methods that we generally follow while calculating the algebraic limit. Clear? And in our previous class, we have already talked about the direct substitution method, factorization method, rationalization method. Okay, so from the today's class, we shall be learning about, that is, if x tends to infinity is given, then how we are going to calculate the limit of such type of algebraic functions that we are going to talk today. Clear? And also we will use, if there are some definite forms, if it will appear 0 by 0 and infinity divided by infinity form, then there are some standard rules through which the particular problem can be solved. Okay, so if there will be such type of function will appear and such type of problem will appear, then we will able to solve. So let's discuss what is your how to calculate the limit when the value x tends to infinity is given. Clear? So I am putting my camera off so that I can able to operate uh, then, so that it will be helpful me to calculate clearly. So dear friends, let's calculate the limit of the problem where we have given the problem x is tends to infinity. Okay, so actually there are 3 steps to calculate the such type of problem, and that you must keep in your mind. So first step is write down the given expression in the form of rational function. So whatever the function is given, first we have to write down in this way at your rational function. Clear? And where fx and gx, in this way it is called your what rational function, and where remember this gx should not be equal to 0, we can say. It means here the denominator should not be equal to 0. Okay, if it is not, so if it is not in this form, then you have to first transform into this form. Clear? Then after that, your second step is if. So you have to look into the numerator and the denominator. Okay, you have to see the numerator and the denominator term, and here if k is the highest power of x in the numerator and denominator both, then the divide each term by the numerator and denominator. Okay, by x to the power k. It means first you have to look into the numerator and also the denominator, and you have to check which one is the highest common power. Okay, which one is the highest common power in both numerator and denominator, and you have to divide with that by numerator and denominator. Clear? So whichever the highest power will be there, then suppose for example we are given a function like ax square plus bx plus c, and also we have given dx square plus cx plus f, sorry, ex plus f, we can say. Already it is c is given here. So in this case, the highest power of this both numerator and denominator of the exponent is what? That is x square. Okay, it means 2. It means 2. So we are going to divide both numerator and denominator by x square. Clear? So in this way, whatever the common highest power of both numerator and denominator is there, you have to divide with that term. Clear? So next come to the what? Your third rule. And third step is what? After that, what you have to do? You have to put the limit of this, the limit x tends to infinity 1 divided by x tends to n, this is equal to 0. So wherever this situation will arise or this term will arise, you have to put the whatever may be the in place of this. It is x to the power 2, x to the power 3, x to the power 4, even it is 1 by x, then also we are going to put the limit of this. If x tends to infinity, then the value of this function will be 0. Clear? But here you have to remember that the n should be greater than 0. But n should be greater than 0. Okay? So we'll see how we are going to calculate in terms of this. Okay? So let's take an example. Our first example is given that a x square plus bx plus c. Okay? And it is given that in the denominator dx square plus ex plus f. Okay, and we have to calculate the limit of this where x tends to infinity. So our first task is what? Already in the first step, what we have to do? If the function is not in the rational form, then we have to transform into the rational form. But here already the function is given in the rational form. It means the p by q form. Okay, where q is not equal to 0, it means this term is not equal to 0. Clear? Then what we have to do? First we have to look in, according to your second step, we have to look into the which one is the highest common power of this x term. Okay, so which one is the highest common factor? Here it is 2, x square is given, here dx square is given. It means here 2 is the highest degree. So we have to divide both numerator and denominator by x square. So let's divide both numerator and denominator by x square. Then what we are going to get? So here we will take limit x tends to infinity. Okay, a x square divided by x square plus bx divided by x square plus c divided by x square, which is divided by dx square divided by x square plus ex divided by x square plus f divided by x square. Okay, so what we do? We did that we divide the x square both numerator and denominator. We divide the both numerator and denominator by x square. Clear? So next come to the what? Your next step, what will happen? If you divide this x square cancel out, this x square cancel out. Clear? Then we got in this way, it is a plus p divided by x, because here x square term is that and there is a b is multiplied, though b divided by x plus c divided by x square. Okay, which is divided by, we are going to get d plus e divided by x plus f divided by x square. Clear? F divided by x square, and you have to put the limit x tends to infinity now. So remember, we have taken that if the limit x tends to infinity is given that, and 1 by x square is something given, then that term will be 0. So here this term will become 0, this term will become 0, this term will become 0, this term will also become 0. Okay, so here we can have a divided by d. So what that is coming? A divided by d. So this is your what? The limit. This is your limit. Clear? In this way we are going to evaluate the limit when it is given that x tends to infinity. Okay, so let's take another example so that it would be very much clear for your understanding. Clear? Now let's come to the second example. Here you can see that this function is given, and you have to find out the limit where limit x tends to infinity is given 2x square plus, in the numerator it is given that 2x square plus 4x plus 7, and in the denominator it is given that 3x square plus 6x plus 5. Okay, so what you have to do first, you have to look into the which one is the highest common factor both in numerator as well as in denominator. So we can see that from the both numerator and denominator it is 2x square and it is 3x square minus 3x square. So it means here x square is the highest term we are taking into consideration. So we will divide both numerator and denominator by the x square. Clear? So let's divide both numerator and denominator by the x square. I am writing down this 2x square divided by x square plus 4x divided by x square plus 7 x square, which is divided by minus 3 x square divided by x square plus 6x divided by x square plus 5 divided by x square. So now it is cancel, x square cancel, here also x square cancel, here x and 2 is cancel, here x and 2 is cancel. So what will remain? What will remain after this? It will remain that 2 plus 4 divided by x plus 7 divided by x square, which is divided by minus 3 plus 6 by x plus 5 divided by x square. Okay, now you put the limit x tends to infinity here. Okay, so remember you have to write down always this term. Now they put this value, and we know that according to our third theorem or third step, what you have to do, the limit x tends to infinity, and if it is given in this form, then it would be 0. So whatever the limit value of this will appear in this term, so this term will be 0, this term will be 0 because it is 1 by x form is given, and this term will be 0 and this term will be 0. Clear? So what we are going to get? We are going to get 2 divided by 3 minus 3. So this would be the answer for this solution. Clear? So in this way we are going to calculate. So you have to do at your own this one and this one. Clear? So you have to follow the same procedure at same 3 step. Clear? Then you can able to calculate where the limit value is given. Okay, when the limit value we have to calculate the limit x tends to infinity. Okay, remember here it should be given in this way. Then we are going to follow the 3 types of step. Okay, so next we are going to talk about the different standard limit theorem. So whatever the extra that is your standard limit theorem that is given, that we are going to calculate. Clear? So dear friends, you can see that there are different standard limit theorem that we are going to talk about. Okay, so what are the standard limit theorem? The theorem first that talks about if the limit x tends to a, and it is given that x to the power n minus a to the power n, which is divided by x minus a. If in this notation, if we are going to get some term, then the limit of this would be n into a to the power n minus 1. Here you have to remember that a should be greater than 0 or a should be positive. Okay, so you remember that. So we will discuss in our next actually subsequent classes while deriving the derivative. So that derivative formula, actually this depends upon this first theorem. Clear? So I will talk in the later. So for the time being you should know this. And what is second theorem? The second theorem, according to the second theorem, if a term is given in this notation like the limit x tends to 0 a to the power x, it means here constant is base and variable is exponent. You remember this. Okay, and minus 1 divided by x, which is equal to log base e a. The answer would be the base e a. It means we have already calculated this limit, and the limit of this would be this. Clear? And the theorem third, that is limit x tends to 0 log 1 plus x divided by x, this is equal to 1. And according to a limit theorem 4 or standard limit theorem 4, there is limit x tends to 0 e to the power x equal x minus 1 divided by x, which is equal to 1. And theorem 5th is that limit x tends to 0, 1 plus x whole square whole to the power n, we can say 1 plus x whole to the power n minus 1 divided by x. Okay, this is equal to n. So limit of this would be n. So we shall going to discuss one by one. Clear? And remember here, the limit x tends to 0 e to the power x, if it is given that we have to find out the limit x tends to 0 is given, and we have to find out the e to the power x. It means that what, in place of 1 you put the value of x, that would be e to the power 0, or which is nothing but the 1. Okay, so that the limit of this x tends to 0 e to the power x, this is equal to 1. And also we can have the limit x tends to infinity x to the power n, this is equal to 0. It means that here if you put x to the power infinity, that would be 0. Clear? And where you have to remember that the x would be lie in between x and 1. Clear? Okay, then next come to the what, let's take an example how we are going to calculate this. Clear? So we'll take the first example. Okay, then we'll see how we are going to calculate this one. Okay, so in our first example it is given that limit x tends to 9 3 limit x tends to line x to the power 3 by 2 minus 27, which is divided by x minus 9. Clear? So how we are going to calculate the limit of this, and which standard theorem will be applied here, that we are going to talk about. Okay, so let's see. Here you have to remember that this is the first theorem will be followed here, because it is in this notation it is given that x to the power n minus a to the power n, and which is divided by x minus a, like that. It is also given that x minus 9 in this format. So here you have to notice that here the 27, this 27 can be written as in this way. If you want to transform in this form, then what will happen? Here we know that so we can say that this 27, this can be also written as that, as we know that 9 to the power, we can say this can be written as in this way also, because as you know that 9 to the power 1 by 2 into 3, this would be root over of 9 and cube, and this should be on root over of 9 means 3, and 3 to the power 3, this is equal to 27. Clear? So for this 27 we can write down this notation, and this is nothing but the 9 to the power 3 divided by 2. Okay, 9 to the power 3 divided by 2. So we can able to explain this. Okay, we can able to write down in this format. Clear? So let's see here, it is given that in this format, the question is given in this way, then we have to calculate this. And I have already told you that in place of 27 we can write down it as 9 to the power 3 by 2. Okay, clear? Because 9 to the power 3 by 2, this is nothing but the 9 to the power 1 by 2 into 3. Okay, and 9 to the power 1 by 2 is nothing but the under root, and this is equal to cube. If you take, then what will happen? 3 cube, this is equal to 27. Okay, so in place of 27 we can write down 9 to the power 3 by 2. Clear? So that what will happen? We got a common exponent, that is 3 by 2, 3 by 2. Okay. So right now you can able to do in this way, according to our first theorem, that is x to the power n minus a to the power n. Here n is an constant, arbitrary constant. Clear? So let's see here what will happen. Next step, what will happen here? So let's take, as you know that this is, now you can directly substitute your formula. Now you can directly substitute your formula in this way. Okay, so what is the formula of this? Then what will happen here? Your x to the power n is 3 by 2 n. Here it is n equal to 3 by 2. Okay, so write down this one according to this formula, n 3 by 2 here. Clear? And x, here it is x also we are taking. Clear? And sorry, so we write down this one, and this is 3 by 2. And what is your constant? It is given, a is given 9, there is 9. And n, what is the n? That is 3 by 2. Okay, minus 1. In this way what will happen? Let's solve this one. After solving this, what you are going to get? Let's solve this. 3 by 2 and n to the power, as you know that 3 by 2 minus 1, this is equal to 3 by 2 n to the power here 2, and we are going to get 3 minus 2. Okay, so what will happen here? Stick here, 3 by 2 9 to the power minus 1 by 2. Okay, so sorry, we will get not minus 1 by 2, only 1 by 2, only 1 by 2, because sorry, I mistake, don't mistake there. 3 by 2 minus 1, this is nothing but the 2. Okay, so here this will be 3 minus 2, this is nothing but the 1 by 2. Clear? This is nothing but the 1 by 2. So what we got? We got that 3 by 2 9 to the power 1 by 2, and this is nothing but the what? This is nothing but the 3 by 2 root over of 9, and this is nothing but the 3 by 2 into 3. Okay, so now what will happen? This term would be 9 divided by 2. Okay, so this is your exact answer. This is your exact answer. Clear? In this way you can get, the next problem also. Clear? In this way you can get the next one, your next problem. Second problem is also, it is given that in the notation, and if you put the value of x tends to a here, if you put the value of x tends to a in this equation, or in this function, then what will happen? X to the power m. So here in place of x, write down x tends to a to the power m. A to the power m minus a to the power m, already it is given, and divided by, in place of x you have to put a, then a to the power n minus a to the power n. So we are going to get a 0 divided by 0 form. If you put, if here the limit x tends to 0 is here. Clear? So what will happen? If x tends to a, it is given, so you are going to get this one. Clear? So next come to the what? How we are going to solve this one? How we are going to solve this problem? Clear? So here you can take, as you know that if it is given that a divided by, if you multiply a d, the numerator, and also divide a that particular d in the denominator, then also we are going to get the same function. So to cancel out, what we did here, we multiply x minus a and divide also x minus a in this notation, because we have to transform this into this, so that we will get in this form. Okay, so here what we did, you multiply x minus a in the numerator and also x minus a in the denominator, so that the first term this term we get in this particular notation. Okay, but this term is not in this notation, so you have to transform this one. So it is multiplication is given, we have to divide them, and if the you have to convert into the division, then what will happen? It will the reverse, the denominator will come to the numerator and the numerator will come to the denominator. Clear? For example it is given that a by b into c by d it is given, then what we will do? A by b divided by d by c, these are the same thing. So in this notation it is given, so we have to transform this into the division form, so that what will happen? This denominator will come to the numerator and the numerator come to the denominator, so that we will get a such type of form and our formula can be applied, the first theorem formula can be applied. So we transform this into the two form, and now put this limit, now put the limit separately, and after putting the limit, what we are going to get? As you know that according to this formula, this formula, what we are going to get, or according to first theorem, what we are going to get? For the first term we are going to get m into a to the power m minus 1, okay, which is divided by m. For the second, that we are going to get n into a to the power n minus 1, okay. So we can write down that m divided by n a to the power m minus 1 minus n plus 1. As you know that according to your exponent rule, so here we can express this one, writing down clearly, m a to the power m minus 1, which is divided by n a to the power n minus 1. Clear? So for this notation we can able to solve this one in this way. This is m divided by n, okay, and here the base is same. So if the base will be same according to your exponent formula, then what we can do? This is m minus 1 and minus, we can take n minus 1. Clear? So what will happen? After this we are going to get m divided by n a to the power m minus 1. So if you open the bracket, then what will happen? This is minus n plus 1. So we are going to get in this notation. So after solving this, plus 1 minus 1 cancel out, what we are going to get? We are going to get m divided by n a to the power m minus n. So this is the your exact limit when limit x tends to infinity is given. So in this way I solved two problems. So you have to calculate the third one, you have to calculate the fourth one, and you have to calculate the fifth one. Okay, clear? So let's take another example for the theorem second, how we are going to deal with such type of problem. Clear? So you can see that the problem number third it is given, which will follow the theorem second. Clear? So here what we can, your problem is given that limit x tends to 0, a to the power x minus b to the power x, which is divided by x. So here the formula second or the theorem second would be applied. So remember here it is x is given and a to the power x constant to the power, actually your variable is given, and here also constant to the power variable is given. So in this way we are going to deal with the theorem second. So here which formula would be applied? Your second theorem formula would be applied. So what is the formula of second theorem that we are going to get? According to the second theorem, if your limit x tends to 0 is given and a to the power x is given, which is minus a divided by x. So the limit of this would be log base e a. Clear? So now we are going to apply this rule. So let's see the problem. So now solve this problem. Here you have to notice that as though it is given that b to the power x, so you have to transform into the formula, and so that solve you have to in this way. So here I added, if you add, for example, an equation is given a plus b and c plus d. If you add minus 1 here and also plus 1 here, the value would be remain same. Then here the same thing is done here. Why it is done? Because to arrive this type of notation, and if we arrive the such type of notation, then what will happen? We can able to apply the second theorem. Clear? So here we can write down that a to the power x minus 1 plus 1 minus b to the power x. We add minus 1 and plus 1 here, so that the value of the function would remain same. So here x divided by x is given. So now you separate each term. Now you separately write down the each term. Then separately write down the each term. So then what will happen? A to the power x minus 1 divided by x plus, okay, plus here 1 minus bx divided by x. So you have to notice that if it is given 1 minus bx, if it is given 1 minus bx, so by taking a minus sign we can able to change this bx into first, and this is equal to 1. It means I want to say that if this is given that this is 1 minus bx, then so you now take a minus sign, then what will happen? If you will take a minus sign, this would become the minus 1, okay, and this would become the, we can have 1 minus bx. If you take a minus sign, then what will happen? What we are going to get? We are going to get this 1 plus 1 will become the minus 1, and this minus bx would become the plus bx. Clear? As we enclose or open the bracket, we can say, then what will happen here? This would become minus 1 plus bx. Right now I can write down this bx first, then all in this way minus 1. Clear? So here it is written in this way. Here it is written in this way. What the minus sign is taken, and we got this term has been written in terms of b to the power x minus 1, taking into the minus sign here common. Clear? So what will happen in this way? After that we are going to get separately this limit and this limit. Now you put the formula second, then you will get this one. According to the formula second, so what will happen to the first term? Limit of the first term, limit of the first term would be g log base e a minus the limit of the second term would be log base e b. Okay, and as we know that there are different log formula, and according to the log formula, this can be written as, if it is minus is given, then it is written as log base e a divided by b. Okay, so this is your actually answer, and this is the limit when x tends to 0 is given, and in this notation it is given. Okay, so you will do such type of thing, you will solve this one, and also you will solve this one. If there will be any problem, then we will discuss in our subsequent classes. Okay, so this much for today. We shall learn in next actually subsequent classes. We are going to learn about what is the meaning of continuity, and how the continuity of a function can be derived in an interval, okay, and at a point. Clear? Then after that we will move towards the derivative and integration part or the calculus part. Clear? So this much for today. Thank you. Have a good day ahead.